Okay, good morning, everyone. Okay, so today, we continue. Okay, for our next lesson. I think we stop until here, right? Okay. So how to describe wave? Okay, can you give me like 1 minute? I have to open my phone. Okay. So wavefronts. Okay, amplitude, wavelength, period, frequency, speed of wave. Okay, so before this we already learned to differentiate between the longitudinal wave and also the transverse wave, right? Okay, so now we will see how to find the amplitude, the wavelength, the period, the frequency or the speed of wave. Okay, so characteristic of wave. Okay, so this is the wave, right? And this is the direction of the propagation, and this is the water wave, right? So you can see as the depth of the water, okay, as the depth of the water decrease, you can see the ripple. Okay, the water ripple become increase. Okay, so you can see the ripple of the water it become increase. Alright, so a profile of water wave in a pond. So what changes can be observed as the wave propagates across the water surface? You can see the ripple become higher and also it become closer to each other. So here imagine that the screen is the surface of a still water, right? So what do you think happen if you dip a finger into the still water? So it can produce the wave, right? And the wave in the circular shape, okay? And the wave and it propagates, right? It propagate, it move upward, okay, from the circle or from the center of the circle, okay? And as you can see here, this is called, we call it as the wave front, okay? So all the circular shape, we call it as the wave front, okay? So the dark and the bright lines are called wavefront. So this one you can see the bright one. Okay. So this is called as the wavefront. So a wavefront is the lines, okay, joining all the points at the same phase. So this one means all the lines here are in the same phase. So they join all the phase, okay, and we will produce the wavefront like this, the circular one. So a point source emits circular wavefront and a long straight source will emit a plane wavefront. Okay. So if you this one is, let's say you dip your hand only 1 point. So if 1 point, let's say this the wave source is 1 point, like if you dip a finger, okay, if 1 point then it will produce a circular. But they say it's the point of source is the plane source, okay, so it will produce the long straight source, okay, long straight wavelength here, okay, long straight wavefront, okay. So this is the different. If you dip like 1 point, if like 1 point only, so it will produce circular, but it's in a plane, okay, the source is the plane shape, so it will produce the plane wavefront. Okay, wait for a moment. Okay, so here it says, all right, to study the amplitude, right? The amplitude, the period, the frequency of wave, and also the wavelength. So what does it mean by the complete vibration? Okay, so the movement from one extreme position to the other and back at to the same position. So let's say if you start at point P, right? So remember when you do the experiment for the oscillation, the pendulum oscillation. Okay, so I remember I told you, if you want to calculate one complete oscillation, if you start at P, so if we oscillate to Q and R and go back to Q and go back to P, so that we call it as the one oscillation. Okay, so that we call as the one oscillation. Okay, so and then it says here you have to displace the pendulum bob, okay, and the slotted weight, okay, and mark the position when the bob and slotted weight at rest with letter X. Okay, so this position is known as the equilibrium position. Okay, now you have to displace the pendulum bob, okay, and also the slotted weight here. Okay, and then you have to mark the position when the bob and the slotted weight at rest with letter X. Okay, so what position is the letter X? Okay, which position that we call it as a letter X, the equilibrium position?
Q.
Yeah, Q. Okay. Q is the equilibrium position, means there is no force that exerted on it. So let's say if you wait some time, so it will stay stationary, right? It will stop. So it will stop at Q. So Q is the equilibrium position. Okay, so where the pendulum stop or where the slotted weight stop. Okay, so both is at Q. Right, so let's say this one it asks you to write the correct path for the one complete oscillation. So it start with PQR, okay, and go back RQ, P, and also then after that that is called as the one complete oscillation. So let's say for the spring. So can you give me the one the correct path for the one complete oscillation for the slotted weight?
AQBQA.
A Q A O. Actually, that one is O. A O B O
OA.
A. Okay. O, and then other any other answer other than that? A O B O A. All is A O B O A. Okay. So let's see whether it's correct or not. Okay. So the answer is O B O A O. Okay. I can you give me like 2 minutes? I need to change my laptop. Wait for a moment. Oh. Okay, can you hear me now?
Yes, sure.
Okay, sorry. Right, so we continue. So that's correct. So that is actually one complete oscillation. So actually it start from O, not start from A. Okay, so actually it start from O here. This is the equilibrium position. Then you drag it to the drag it down. Okay, drag it down, and then it go back to O and go back to A. Then it go back to O. Okay, O is the equilibrium position. Okay, start from O, and then you start from B and go back to O, then go back to A and go back again to O. So this is called as the one complete oscillation. Okay, so this is called as the same phase. Okay, so the crest, 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 crest. So all this is the same phase. So what you see in the wavefront here, the bright lines is actually the crest. So if you connected the crest to the crest, okay, and to the next one, okay, and also to the next crest. So if you connected x1, x2, x3, and x4, so all these called as crest, and they're all in the same phase, so they will produce the bright lines. Okay, the bright lines. Okay, but if you connected this one, we call it as a throw. Okay, so z1, z2, and z3, so all in the same phase, there is a throw. If you connected it, we will call it as the uh, throw. Okay, this is called it as no, this will produce the dark lines. Okay, the dark line is the throw, the bright one is the crest. Okay, and they must be connected in the same phase, x1, x2, x3, x4, and z1, z2, z3, okay, also must be in the same phase. So this is called as the same phase. Right, and also this is for the water wave. Okay, what about in the sound wave? Okay, for the sound wave, okay, the same phase is actually from the compression to the compression, or rarefaction to the rarefaction. Okay, and also we already discussed from the compression to the compression, this is called as 1 lambda. Okay, this is called a 1 lambda. Or rarefaction to the rarefaction, okay, so this one is also called as the 1 lambda. Okay, 1 lambda means 1 wavelength. Okay, so let's say we have a graph here. Okay, the amplitude, right?
At the water waves. Amplitude is the maximum displacement from the equilibrium position.
So this is the meaning of the amplitude, the maximum displacement from the equilibrium position. Okay, so this is the equilibrium position. Okay, so this is the maximum displacement. Okay, this is called as the amplitude. Okay,
At the water waves from the equilibrium position. The symbol for amplitude is A. The SI unit for amplitude is meter. A mass M is hung to a spring. The spring is at rest or in its equilibrium position at O. Click the Start button to oscillate the spring. What is the amplitude of the oscillation? The amplitude A is the distance from the equilibrium position O to the maximum displacement, X or Y.
okay. So here just now this is the equilibrium position, right? So it drag the slotted weight until point X. Okay. So from O to X, that is called the amplitude, the maximum displacement. How far does the slotted weight being moved? Okay, the maximum distance. So how far does the slotted weight, okay, being dragged down? So this one, the OX, we call it as the uh, amplitude. Okay, and then if we go up, right, so we start oscillate. So let's say you drag until OX, and then if we go up, okay, to O, then if we goes to Y, right? So OY also we call it as the amplitude. Okay, and the length of the both are same. So let's say this is 3 cm. Okay, OY also 3 cm. Okay.
Look at the girl swinging on a swing. Determine the amplitude from the motion. The amplitude A is the distance from the equilibrium position O to the maximum displacement, x or y.
Okay. So let's say if I give you an example. Okay. So alright. So let's say if I have a pendulum here. Okay. So I try to move it here. I move it until this is point B, so until 5 cm. Okay. And this one also this is point C, this one also should be 5 cm. So what is my amplitude here?
5.
5, yes, correct. Okay, so let's say if I have another one. Okay, all right, so it's oscillate. Okay, and I give the distance is 20 cm. So what is my amplitude here? Yeah, 10 cm. So 10 cm, this one also should be 10 cm. So the amplitude is 10 cm. Okay. Okay, so it said what does it mean by amplitude? So the maximum displacement of the object from its equilibrium position. Okay, so I already explained just now, right? So if you drag O to P, so OP is actually the maximum displacement. How far does the pendulum move? Okay, and this one for you have to mark a label with a letter E for amplitude in the oscillated and vibrating system on the above diagram. So this is called as A. This one is also A. Okay. This is the amplitude. Okay.
Watch the pendulum swinging back and forth. When the pendulum swings from A to B and back to A, the pendulum is said to have done one complete oscillation. The time taken for one complete oscillation is known as its period.
Okay, so period is the time taken for one complete oscillation. So let's say if you swing from point A, okay, and then it goes to the equilibrium position, goes to point B, back to the equilibrium position, and go back to A. So this is called as the period. Okay, so the time taken for it to make a one complete oscillation. So remember this one also we already do the experiment, right? The pendulum. Okay, if you want to take the time, okay, you have to take the time for 20 complete oscillation, right? And then you have to divide by 20 to find the period of the oscillation. Okay, so the period is the time taken for one complete oscillation. So how much the time taken, okay, by the pendulum to make one complete oscillation, okay, starting from point A, then also it have to end at point A. So that one we call it as the one complete oscillation.
The symbol for period is T.
Okay,
The
capital
SI
letter
unit for
T.
period is the second.
Okay, the unit is in second.
Click on the Start button. Count how many complete oscillations are there in 5 seconds.
Okay, so 5 seconds, you got 10 oscillation, right? For 5 seconds, you got 10
The
oscillation.
plasticine ball made 10 complete oscillations in 5 seconds. Calculate how many oscillations the plasticine ball make in 1 second.
So this one you have to divide, right?
The ball made 2 oscillations in 1
10
second.
divided by 5.
The number of complete oscillations made in 1 second is known as frequency.
Okay, so just now, sorry. Just now is the
Calculate how many
period. Period is the time, okay, how much the time take to make one oscillation. Okay, one complete oscillation. But for frequency, how many oscillation made in 1 second? Okay, so for just now we already learned there are 10 oscillation and it takes 5 seconds. Okay, so if you want to find how many oscillation in 1 second, so you just divide 10 by 5. So this one we call it as frequency. Okay, so you have to remember the meaning. So the period is the time taken for one complete oscillation. Frequency is the how many oscillation made in 1 second. Okay, so if you want to know what is the frequency, you have to divide how many oscillation, okay, and then divide the time taken for the oscillation. So this one is
oscillations, the plasticity
2 hertz. Okay, the unit for frequency is hertz. Okay, 2
2
hertz.
oscillations in 1 second. The number of complete oscillations made in 1 second is known as frequency. The symbol for frequency is F. The SI unit for frequency is the hertz, or the second.
Okay, so this one state the meaning of period, the time taken for one complete oscillation. Okay, what does it mean by frequency? Frequency is the number of complete oscillation per second. So this is the meaning of period and also frequency. Okay, so for this question, I want you to try first. So you have to find the time taken to make 10 complete oscillation. A, B, and C. Okay, for A, anyone want to try for A? 5 seconds. Okay, so it take 5 seconds. Okay, or 5s. Alright, so here determine the period. So the period is what's the meaning by period? The time taken for one complete oscillation. So what's the answer for B? 2 oscillation per second. 2 oscillation per second. So any other answer? 0.5 second. So some of you put 2 seconds, some of you put 0.5. Okay, so here you can see determine the period. Period is the time taken for one oscillation, right? So it should be 5 seconds divided by 10. Okay, so 5 divided by 10, so you get 0.5 second. So means for one complete oscillation it take like 0.5 second. Okay, so the answer should be 0.5. Okay, so that one you calculate uh two we got 2 seconds, right? 2 seconds is actually for the frequency. Okay, for the frequency. Okay, so for this one is actually 0.5 second, right? So because 10 oscillation, okay, 10 oscillation is equals to 5 second, right? If you want to find one oscillation, so you have to divide by 10. So 5 divided by 10, you got 0.5 second. Okay, so 10 oscillation is equals to 5 second. If you want to find one complete oscillation, So you have to divide by 10, right? So 5 divided by 10, you got 0.5. Because period is the time taken for one complete oscillation. Okay, for the C frequency, so frequency is, what is the frequency? 2 hertz. Okay, for this one, you can use the formula F is 1 over T. Okay, so 1 over T means 1 over 0.5. So you will get 2 hertz. Okay, so this is the formula for frequency. F is equals to 1 over T. Okay, how many second, how in 1 second, how many how many complete oscillation that the pendulum can make. Okay, so this one is 1 over T. Okay, how in 1 second, how many complete oscillation can be done, right? So the answer is 2 hertz, and this is the formula. Okay, okay, so you got 2 hertz. Okay, period is the time required to complete one oscillation. So this is the calculation just now, and frequency is the number of complete oscillation per second. In 1 second, how many complete oscillation can be made? Okay, so this is the calculation just now, or can use the formula 1 over T. Okay, so compare the two formula. How is period related to frequency? Okay, so this is the formula. F is equals to 1 over T. Okay, T is the period, right? So if you want to calculate the frequency, you have to know for one complete oscillation, how much the time taken. Okay, okay, so this is a formula, and this is the unit for frequency. Okay, S negative 1 is actually equals to hertz. Okay, for the next one, we have to see what does it mean by the wavelength. Okay, so wavelength is the distance between two consecutive points in a phase. Okay, so this one they say from crest to crest or from throw to throw. So this one we call it as a one wavelength. Okay, so let's say if I give you a graph like this. Okay, how you want to find one wavelength? So it's from here to here, crest to crest. This is also count as one lambda. Okay, this one also throw to throw. Okay, so this one is also one lambda, one wavelength. Or you can take two semicircle. Okay, two semicircle here is also called as one lambda. Okay, whether it's crest to crest or throw to throw or two semicircle, the distance for two semicircle, this is called as the wavelength. Okay, so wavelength. This is the symbol for wavelength, lambda. Okay, so wavelength is the distance between two consecutive points in same phase. So you can see in the same phase, right? Crest to crest, throw to throw. Okay, and the wavelength is the distance between the two successive crests or throws. Okay, alright, this is for the water wave. Okay, for the transverse wave, right? Let's say for the longitudinal wave, how you want to find the wavelength is from the compression to the compression, or from the refraction to the refraction. Okay, so you have to remember from the compression to the compression, or from the refraction to the refraction. So that what we call it as the lambda. Okay, as the lambda or one wavelength. Okay, so for this one, okay, you have to mark and label the wavelength. Okay, so let's say if I make a line like this. Okay, so from here to here is 1 lambda, or from here to here also 1 lambda. Okay, or from here to here also is 1 lambda. Okay, so you have this label in the diagram. Okay, for the compression, okay, for the longitudinal wave, okay, so it's from here, okay, to here. This is called as 1 lambda. Okay, from compression to compression, and here from here to here is also called as 1 lambda. This is for transverse wave. This is called for longitudinal wave. Okay.
Teacher,
Yes.
the longitudinal wave one, we have to go from the first line of the compression or the refraction, right?
It doesn't matter. Let's say if we take from the second line, it have to be to the second line too. Second line to second line. Or first line to first line. That is still called as one wavelength.
Oh, okay, sure.
Okay, the next one you have to find the speed. Okay, so speed is the distance travel per unit time. Okay, so V is equals to S over T, right? So the SI unit is meter per second. Okay, the speed of wave is the distance traveled by a wave per unit time. Okay, so the speed of wave is the distance traveled by a wave per unit time. So distance divided by time. So the speed of wave tells how quickly the energy which is carried by the wave is being transferred. Okay, so this is the example. So how does the speed wave travel here? You can see. All right. For this one, okay, I will stop share first because this one I need for your response. Okay. For a moment. Okay, I will give you a link. Okay, a link in the Google Meet. Okay, so I want you to join the link. This one, all of you have to give response to me. So I want to see whether you can understand or not. Okay, okay, we wait for 6 more students. Two more. Anyone have problem to join? Two more student. One more. Who's still not joining? I cannot check here. Oh, whose laptop lagging? Krisha, you cannot join. Is it? One more student who still didn't join? Oh, okay, it's okay. Abi Rami, you cannot join. Then maybe you just see my after done how to turn it in. Later, wait, because I didn't start my lesson yet. When you start your lesson, I can see your response. Oh, okay. So we just start without. Okay. So I will share my screen for those who cannot join. Okay. Here. Okay. So you already gave me your answer. Is it? Only 6 of you. Okay. So for this one, you have to diagram 1 shows a wave traveling in the sea starting from point A. So you have to indicate the interval which represent one wavelength. So from which one to from point what to point what, which one is the, we can call it as the one wavelength. Okay, let me see your response. B to F. B to F, left to right, 4 cm. 4 cm. This one you put A to C. Just use the words given, the alphabets. Um, put here in the box here the questions. A, E, B, F, C, G. Okay, that's a lot actually. A, E, B, F, C, G. Right. Okay, and then same face A, E, and E. A, C, E is the same face, right? B, F in the same face. Okay, C, E, G in the same face. Okay. We can put your text here. You can see there's the A. Wait, let me see here. You can see the words T there, right? Okay, you can click the word T there, and then you can put it where you want to type. So you don't need to use your mouse to type. You can use the word T there. You see the symbol T there? Okay, click that one and then click where you want to type. Okay? Alright. A, C, C, E, G, B, F, B, F. Okay? B to F, A to E. Okay, so how many of you give me? Okay. So that is the wavelength, right? So the answer can be from AC, okay, AC, AE, okay, sorry, AE, CG, BF, okay. So that one is all we call it as the one wavelength, okay. And here it says here, you have to state the pairs of point, right, which are at the same phase. So the same phase here is BF, okay, or AG or CE. That one is the phase in equilibrium position, okay. So that is, we call it as the same phase, okay. And the next one, you have to state the direction of the propagation. So this one is from, because it start from point A, right? So from A to G is from left to right, okay, from left to right, okay. So here for number 2, you have to calculate the wavelength, okay. So let me see how you calculate your wavelength. 5 cm. Is it 5 cm? Is it correct? Yeah, some of you answer 4 cm. Okay, so the answer should be 4 cm. Okay, because you can see there are 5 wavelength actually. 1, 2, 3, 4, 5. Okay, so maybe you can see my screen. Okay, it means you have to open 2 screen. Okay, next to each other. The first one I will present using my Google Meet, and the second one is your screen. Okay, if your answer for your answer. Okay, so this one is actually 5 wavelength. Okay, 5 wavelength. 1, 2, 3, 4, 5. Okay, so 20 divided by 5, you will get 4 cm. Okay, so the answer is 4 cm. Are you clear for that one? Yes. Okay, 20 divided by 5 is 4 cm. Okay, for those who put 5 cm, okay, so this one, okay, so you have to make a correction here. Okay, 1, 2, 3, 4, 5. So 20 divided by 5 is 4. Right? Okay, are you clear about this one? How to find the wavelength, how to find the pairs of point that in the same phase, and the direction of the propagation? Is it okay? Anyone have a question?
Okay, sure.
Okay. All right. So I move on to the next slide. Okay, for this one, it says here, diagram 3 shows a steel ruler which is clamped to a table and is oscillating between the paths A, B, C, B, A. Okay, so it says here the time taken to oscillate 10 complete oscillation is 8 seconds, and a distance AC is 12 cm. So you have to determine the amplitude, the period, and also the frequency. Okay, so try to answer this one. What is the amplitude? What is the period? So remember, the period is the time taken for one complete oscillation. Okay, for frequency, you can just use the formula 1 over T. 6 cm. Okay, 6 cm. Okay, others? What's the amplitude here? The period is 8 over 10. Hmm. One over T, 12 divided by 2, 6 cm, 8. Teacher, my one said it's loading for a long time, so I can answer now, but just now I can. Oh, okay. I just want to try whether it's okay. Okay. Uh, this is the first time I'm using this one. So mostly of you got it correct. Okay. Who says here 12? Okay, so this is not 12. The amplitude is 12 divided by 2, right? Only from A to B we call it amplitude. Or B to C is amplitude. Okay, so you should divide by 2. Okay, so the answer should be 6. Okay, O A B is 1 amplitude. B C is 1 amplitude. Okay, so means 2A is equals to 12. Okay, so means A you have to divide by 2. 12 divided by 2 you will got 6 cm. Okay, so for this one who did this 12, so can you make a correction? 6 cm, 0.8. 10 divided by 8 or 8 divided by 10? This one 6 divided by 8? No. Okay, alright. So let's discuss. Okay. So if you use laptop, I think it's easy for you to open like two tab like that. Just change your tab, right? Okay, but for this one, for those who are using phone, maybe it's quite hard for you. Okay, so amplitude, alright. So here how to find amplitude. So amplitude is 12 divided by 2. Okay, 12 divided by 2, so you will get 6 cm. Okay, 6 cm. Right? And for the period, it says here the time taken for 10 complete oscillation is 8 seconds. Okay, so mean for 10 complete oscillation, okay, so you need 8 seconds. So if the period, what does it mean? The period is the time for one complete oscillation. So if you want to find the time for one complete oscillation, so this one you have to divide by 10, right? So 8 also you have to divide by 10. So 8 divided by 10 you will get 0.8 second. Okay, so for this one the period is 0.8 second because 10 complete oscillation is equals to 8 seconds. Sorry, not 8 cm, 8 second. Okay, and then for one complete oscillation, so 10 to 1 is divided by 10. So 8 also you have to divide by 10, so you will get 0.8 second. So one complete oscillation 0.8 second. Okay, for frequency we just use the formula 1 divided by t. So 1 divided by 0.8. So you will get 1 divided by 0.8 is 1.25 hertz. Okay, so that's the answer. Okay, so let's check your go back here. Okay, so are you clear how to answer for this question? 1.25 hertz. Just now I saw someone put 0.75. Okay, right. Okay, so everyone, only two people didn't answer. Who didn't answer for this one? Oh, three people didn't answer. Never mind, check later. Okay, so are you clear about that one? Any question you want to ask? How to find the frequency, the amplitude, and also the wavelength just now? Any other questions? Is it okay to use this one to get your response, or to use these apps. So later, can you give me a feedback? Okay. Uh, all right. It's okay, right? Because this one, it's not for hard for you to type because you can type using the text, right? Oh, okay. So next time, if for the question part, we use this one so I can get a response, okay, from all of you. Either then in the chat room, only like 2 or 3 people will answer, right? Okay. Okay. So I think I will stop until here. Okay. So we continue tomorrow. Okay. So see you tomorrow, class. Okay. So thank you.
Thank you, teacher.
Teacher.
All right. Thank you.
Thank you, teacher.
Thank you,
Bye, teacher.
teacher. Bye,
Right.
teacher.
Bye. Bye.